This instructional video shows you how to use the RTExec malfunction setup and execution features. I'll use the malfunction setup features to create and organize the malfunctions, and the malfunction execute features to initiate one or more malfunctions on the running simulation. Malfunctions are most commonly employed during training sessions, in which a trainer can invoke one or more malfunctions and assess the learner's response in recognizing the malfunction and taking the proper countermeasures, if any. Malfunctions are also employed in failure analysis to assess the consequences of system failures and designing process and controls improvements to mitigate them. We begin with the gas-fired boiler model loaded in our RTExec session at a 200 megawatt initial condition. The demonstration malfunction will focus on these natural gas fuel supply valves. Each gas valve supply header is configured to be identical. Each of these gas supply valves controls the fuel flow rate to a corresponding burner. The malfunction we create will cause the fuel valve to fail closed. In response to this failure, the control system will increase demand to the properly functioning valves in order to bring fuel flow back up to normal levels. For the remainder of the video, I'll show only this portion of the process schematic, which we will use as an aid in creating and visualizing the malfunction. I'll also display this dynamic trend when appropriate, showing valve position demand, total fuel flow, and the flow through each of the three gas supply valves. As the total fuel flow is split equally amongst the three, fuel flow plots from these individual headers will overlap at times. We're going to add these new malfunctions to our current master set. We access these existing sets of malfunctions via the Malfunction Setup menu. We can initiate the malfunction setup from the Malfunctions toolbar, or we can navigate to it via the Malfunctions menu as shown. Initially, no malfunction file set is loaded, so we'll use the load key to present the set of malfunction files in which the permanent malfunction configurations are stored. These files have a .mlfx suffix, but may have a .mlft or .mlf suffix with older systems. I'll select the desired malfunction file and open it. The dialog box defaults to Tree View. In Tree View, the malfunctions are separated into groups that can be expanded and collapsed for better organization and easier browsing. I'll expand each of the malfunction group folders to reveal the individual malfunctions, grouped in categories such as air, electrical, feed water, and steam. Any malfunction not assigned to a group would appear under the No Group list. Also note that one can view all malfunctions in a single list using the List View button. I'll now bring back the gas header section of the process schematic to aid in configuring our first malfunction. Let's start by configuring a malfunction for the first gas control valve. Right-click on the valve and select Create Malfunction from the pull-down menu. A standard malfunction editing dialog will appear. The reason that this is the easiest method of malfunction configuration is now evident, as the model in which the equipment resides, the type of module used, and the identifier of that specific item, in this case valve 1, are pre-populated in the dialog. But before we finish its configuration, I'll substitute the default description for the malfunction with something more meaningful. A good description includes the nature of the malfunction and the specific piece of equipment to which it applies, so I'll call it Gas Valve 1 Fails Closed. The last essential piece of the malfunction configuration is the failure mode. Let's open the failure mode pull-down menu. You can see for a module of this type that I have the option to fail the valve closed, fail it open, have it stuck in place, or have its shaft break. Other modules have their own set of standard malfunctions. You can find out more about these standard malfunctions in the Analyst Instruction Manual via the Help menu. I'll select the Fail Closed failure mode in this particular instance, then select OK to complete the configuration. You can see that the new malfunction has been assigned to the No Group set. As I don't have a malfunction group set to which this malfunction should be assigned, I'll create a new one. Right-click into the Malfunctions field and select Add Group. I'll enter Fuel as the new group name and select OK. Left-click and hold the new malfunction, then slide it over to the Fuel group. When I open the Fuel group, you'll see the new malfunction listed within it. I'll next create a malfunction for the second gas feed valve in the same way I did the first. Let's jump ahead in time to the completion of its configuration. And then the third gas feed valve in the same way I did the other two. Let's jump ahead in time to the completion of its configuration. Remember that none of these configuration changes are permanent until you save the malfunction file. Select the Save button to initiate the save. I'm saving over my original malfunction file with the extended set. Before we move on, note that if I right-click into a group name, I'll have the option to add a new malfunction or to delete the group and all its contents. If I select Add New Malfunction, a pop-up menu appears in which I can create a new standard malfunction or a new custom malfunction. Although we don't cover custom malfunctions in this video, you may want to consider this option should a standard malfunction not be exactly what you need. Let's cancel out of that menu and right-click into the Gas Valve 1 Fails Closed malfunction. If desired, you could edit this malfunction or delete only this malfunction. Now that we've set up our malfunctions, let's demonstrate their initiation on the running simulator. Navigate to the Execution button on the Malfunctions toolbar, or select the Execution shortcut from the Advanced toolbar, or select Execute from the Malfunctions menu as shown. The Malfunction Execution pop-up appears, with all malfunctions available from the malfunction file we just saved. I've expanded the Fuel group to show the 3 gas valve malfunctions that we just created. I'll bring back the process schematic and the dynamic trend window and rearrange them. We're now ready to initiate a malfunction. Let's run the simulator. Again, starting at the 200 megawatt initial condition, select the Gas Valve 1 Fails Closed malfunction and initiate it immediately with the Initiate Now button. In the upper box, you'll see that the Gas Valve 1 Fails Closed malfunction has been initiated and that the execution is complete. Because the valve has failed closed, there's no longer fuel flow through its header and thus no flow to the burner. The dynamic stream color changes from red to gray. The controls detect the loss in total fuel flow as a result of the malfunction and increases fuel flow demand so that the 2 functioning gas control valves will open wider to compensate for the malfunction valve. Over time, fuel gas flow is restored to normal levels. Thanks for watching the RTExec malfunction setup and execution video, in which we created and organized malfunctions and demonstrated the initiation of a malfunction.